Okay, this is our fifth and final section of this chapter, chapter 6, Environmental Quality. And the section is titled, Where Do We Go From Here? A Brief Look. And this is going to be, in some ways, a little bit of a preview of future chapters. And what you see in front of you is a graph of marginal benefit and marginal cost, and it shows the efficient level of sulfur dioxide emissions, tons of emissions. And the point being is that there is an efficient positive level of pollution. And your book goes to say that the marginal benefits from the first few tons of SO2 emissions might be that ambulance can rush accident victims to hospitals. At the same time, a few tons of SO2 spread around the atmosphere might not have any appreciable marginal cost. So at the beginning, benefits outweigh the costs. Now, given that marginal benefits of activities that cause pollution start out high and the marginal costs start out low, some positive level of pollution is sufficient and permissible in the name of human welfare. So we got to have some pollution out there, but the key is to equate marginal benefit with marginal costs. Now, when pollution levels exceed the efficient level, though, the task is to identify which incremental cleanup efforts that provide benefits that exceed the costs. And of course, there are ongoing debates about the efficiency of measures to thwart the major problems that we face, such as global warming, nuclear power, and emission standards for automobiles. Okay, the advisability of other measures is more clear cut. Low wattage light bulbs, low volume flush toilets, and improved home insulation can all cut costs and pollution at the same time, and the benefits may very well outweigh the costs. Okay, this first section is policy implementation. Point sources of pollution that come from a specific area are easier to measure than non-point solutions. Your book has an example of Bergen-Belp Airport in Switzerland. Here, planes landing at this airport pay a landing fee based upon the level of nitrous oxide emissions and the noise level generated by the particular type of aircraft. So people are paying for the privilege of landing at this particular airport. Now, non-point sources of pollution are harder to monitor, and they can be influenced by environmental policy when the manufacturers of the products that cause non-point pollution, rather than the polluters themselves, are effectively regulated. So you regulate the people who are emitting the producers of oil and gasoline, as opposed to those who are driving cars. Now, concentrated pollutants can be controlled locally, and that's much easier to control than distributed pollutants that is extending beyond national boundaries. So much more difficult to control there. And greenhouse gases would be a great example of uniformly distributed pollutants. Okay, this is policy implementation. Next slide, education and new technology. So here we have education. And many citizens do not know how much energy they use and waste. And there are various software programs to take a look at that. One is called Global Carbon Footprint, and this is something that we'll be doing in class. Maybe this chapter, maybe a future one, and it will show you how many Earths if everybody did as you were doing, how many Earths it would take to satisfy all of you folks. Habits can be broken as a result of environmental education. For example, when 75,000 U.S. residents received information on how much energy their neighbors use, those with relatively high levels of use reduced their consumption by upwards of 6%. The most successful programs in environmental education convey knowledge of relevant environmental concepts, provide issue analysis, and involve participants in the resolution of real environmental problems. And we have lots of programs both here at WCC and also in the city and county of Honolulu that engage in a strong dose of environmental education. New technology is also something that can limit pollution, and in particular automotive technology like hybrid vehicles, integrated starter generator systems that prevent idling, and regenerative braking systems that captures energy from braking to help recharge the battery. These all increase the efficiency of a car and enables the car to run on less gasoline and hence increase the gas mileage of the gasoline. The electric vehicles have almost no gas component. A hybrid engine like the Toyota Prius can run on upwards of 55 miles a gallon because it is both part of it runs on battery and part of it runs on gasoline. Now, scrubbing systems for coal-powered electric utilities that can certainly make coal-fired plants much more efficient to run, but they are expensive. The Clean Coal Technology Demonstration Program is a $5.2 billion collaboration of government and industry to foster a secure and reliable energy system. So these are not cheap. And again, I think I mentioned earlier in this chapter, another way of doing this for acid rain is to have a tradable emissions policy. And speaking of which, market-based incentives. These, again, I may have mentioned this before, market-based incentives allow the company to produce, but then they're going to pay a price, the social cost of their actions. So we have tax credits and emissions fees like a carbon tax. So you're paying for the right and privilege to pollute, or a tax credit for pollution abating activities like solar panels. So a tax credit is to increase the positive externalities, and emissions fee is to increase the positive externality, and emissions fee is to decrease the negative externality. Now you can also have emissions trading programs such as cap and trade. And your book talks about the U.S. acid rain program sets a limit or a cap on the volume of a particular pollutant that can be released, and then the various sources receive allowances to emit a set amount, and then they can trade with each other. And when the cap is set below emissions level, the total volume of emissions is reduced. Now, command and control programs. These require uniform reductions or specific technology applications for all sources. For example, a rule that all power plants must employ a cement kiln flue gas recovery scrubber to limit emissions would be easy for some plants to obey and difficult for others. Generally, we economists do not like such programs because they emit a uniform standard on everybody. We tend to prefer tax credits and emission fee or trading programs as opposed to strict command and control. But we will discuss these in more detail in chapter 12. And finally, we have a picture that is actually here in Hawaii, and it's extolling people to dump no waste, and it's going to go into the ocean. Okay, and that ends chapter 6.